Hello everybody, so today we'll be looking at a very interesting technique which is the Riemann limited integral formula, as I like to call it. The integral from a to b of f of x dx is the same as the limit as n goes to infinity of the sum from k equals 1 until n of f of x k delta x, where delta x is b minus a over n and xk is a plus k times delta x. So now if we look at a special case, which is the integral from 0 to 1, so basically that's the limit we're going to be working on today. So if we consider the integral from 0 to 1 of f of x dx, basically that's going to be the same as the limit as n goes to infinity of f of what, xk. First of all, let's evaluate delta x. That's 1 over n, and that's 0 plus k over n, just k over n. So k over n times 1 over n. So that's very important. So that's what we're going to use today, basically. We're going to write the denominator and numerator as limits like these. So the first thing we want to do in order to get our expression right over here is I forgot, yeah, k equals 1 until n. So now what we're going to do is try to write the numerator and denominator like this. So this is equivalent to the limit as n goes to infinity. The key idea is to multiply the numerator and denominator by 1 over n to the power n plus 2. So all times 1 over n to the power a plus 2. And basically that's 1 to the power a plus 2 to the power a plus until n to the power a, all times 1 over n to the power a plus 1. The n and n to the power n plus 2 is simplified to get n to the power n plus 1. And that's the same as the limit as n goes to infinity of... So now I'm going to show the 1 over n that I have right here in my formula. So 1 over n times what? So I'm left with n to the power a plus 1. 1 to the power a plus 1 over n to the power a plus 1 plus until n to the power a plus 1 over n to the power a plus 1. What about here? It's 1 over n times 1 to the power a over n to the power a plus until n to the power a over n to the power a. So now we can rewrite this as the limit as n goes to infinity of... So first of all, let's rewrite this sum. So that's the sum from k equals 1 until n of k over n to the power. So that's 1 over n times the sum from k equals 1 until n of k over n to the power n plus 1. Of k to the power a plus 1 over n to the power a plus 1 over the limit as n goes to infinity of 1 over n times the sum going from k equals 1 until n of k to the power a over n to the power k. Now if we compare these to our formulas right over here, that's pretty much the same thing. That's equal to the integral from 0 to 1 of x to the power a plus 1 dx. And that's equal to the integral from 0 to 1 of x to the power a dx, which is equal to 1 over a plus 2 times x to the power a plus 2. So now we can evaluate these pretty easily. These are just finite integrals. Evaluate it from 0 to 1, and that's the same as 1 over a plus 1 times x to the power a plus 1 evaluated from 0 to 1, which is equal to a plus 1 over a plus 2. So I hope you enjoyed today's video. Please do not forget to subscribe to my channel and like this video for more content.